Use Simpson's rule with 5 ordinates to find an approximate value for this integral here, between 0 and 2 pi over 9. Show your working and give your answer correct to 4 decimal places. Deduce an approximate value for this integral here between 0 and 2 pi over 9. So this is what we've got then. Now we need Simpson's rule, so we go back to the formula sheet and we can click on the formula sheet for Simpson's rule. Here it is, here, h over 3 times bracket, the first and the last y ordinates, 4 times the odd y ordinates in between, 2 times the even y ordinates in between. H is equal to b minus a over n, and n is even, n being the number of intervals. So here, 5 ordinates, so there's 4 intervals, so n equals 4. So let's paste in Simpson's rule from the formula booklet then. I've copied it in here. So this is the formula here, and let's fill out what we've got then. So b minus a first of all, 2 pi over 9 minus 0 is what that is. So let's find out h first. That's 2 pi over 9 then goes here. b minus a is 2 pi over 9. Take away 0 is 2 pi over 9 over n, the number of intervals. 5 ordinates, so there's 4 intervals. So 2 pi over 9 divided by 4 is going to be, the 2's cancel, there'll still be a 2 here, which is pi over 18. So let's just write that down here then. H is pi over 18. So the increment value between the intervals is pi over 18. So now h over 3 then will be pi over 18 over 3, which will be pi over 54. So let's put that in straight away. So that's pi over 54 then, isn't it? Now we need these y ordinates. Now what are we going to? We're going to, n is 4, so this would be 3, wouldn't it? So it's just y1 plus y3. So that's just those two. And then for the evens, n is 4, so it's simply just y2 alone, isn't it, here, for the evens in between. So that's what we've got there. And this value is 4 here, isn't it? So we put the values in the formula then. Let's just move things up properly then now. So let's just tidy it all up. There's 2y of these, and put this bracket as well there. Okay, so that's what we've got then. So we've got h, we've put the h in, so we don't need this anymore. So let's proceed with the problem now and work this out. So we want these y ordinates, so we better get the x ordinates first. So we need x0, x1, x2, x3 and x4, don't we? Okay, x3 and x4. So we start from 0. H was pi over 18, so that's pi over 18. Then it's 2 pi over 18, 3 pi over 18, and lastly we've got 4 pi over 18. So there's our x ordinates then. Now we can get the y ordinates. Bit of calculator work here. So y0 we need, y1, y2, y3 and y4. So it will be log n cos, because that's what the integral is above, here it is here, it's log n cos of x, isn't it? We're working in radians mode, so let's get our calculator then. And it's log n, we're in radians mode we are, so it's ln cos of, the first one would be 0. And we know what that is, it's log, cos 0 is 1, and log of 1 is 0. So that's 0. Next value. So instead of the 0, now we put pi over 18 in, don't we? So pi divided by 18 equals... Right, we're working our final answer to 4 dp, so we better work to 6 dp now. Minus 0.015309, isn't it? 015309. Next one is 2 pi over 18 now. So toggle back and put a 2 times. Minus 0.062202. Minus 0.062202. And that's 6 dp again. Next one. Toggle back and put a 3 in. minus 0.143841. 143841, and it was 0 point with a minus. 143841 with a minus 0 point, and then the last one, 4 pi over 18. Put that in. Minus 0.266515. 266515. So there's our ordinates, the y ordinates we need to put in then. So that's pi over 54. The first one plus the last one, that's that one and that one. So that would be 0 point with a minus 266515 plus 0 is still the same. 4 times the y1 plus y3, which are these two. Okay, and then we've got plus, so I'll just put y1 plus y3 here, and then plus 2y2, because we're going to work it out, aren't we? So let's just work out the number here and put them all in our calculator now. So let's have a go at that. Let's have a look here. We'll put it over here, shall we? So it's out of the way. So we've got pi over 54, pi divided by 54 times brackets y0 plus y4. So 0 plus this is simply minus 0.266515. 515. And then it's plus 4 times bracket, and then it was y1 plus y3, wasn't it? These two here. So it would be minus 0.015309. 15309. And then it's minus 0.143841. 143.841. Close that bracket, that was the 4 times, then plus 2 times, and then it's just a single entry, isn't it, y2, and that would be minus 0.062206, so it's bracket minus 0.062206. Close that bracket, and then close the brace at the end, and that equals minus 0.059. Now we're doing to 4dp when we finish the final answer. So there's the 7, the other one's 7, so this rounds up to an 8. 0598. 0598, and it was minus 0 point, wasn't it? Minus 0.059058, and that was the 4 decimal places. So there's our answer then for this particular integral using Simpson's rule. Now it says deduce an approximate value for this. So if we label this here as I, and then we can work out that value. So here I is equal to now the property of logs, this is cosine squared, isn't it? So the 2 is a power. Power rule for logarithms means it comes down here. So I will equal 2 lots of, so we can take that outside the front of the integral, 0 to 2 pi over 9 of ln cos x. And we've already got a value for this, dx, so it would be 2 times the minus 0.0598. Tap that in the calculator, which we already have. So times this by 2, and we've got minus 1196, isn't it? 1196 minus 0.1196. So there we go. That's the final part completed then.